before I get started, one thing to say is there's not a lot of spatial content here, and it's going to come towards the end. But Git and GitHub and version control are something that really they didn't start in the spatial world. They started more in the realm of computer science and development. Write software who write code and write a lot of code have been using these tools for I don't even know how long at this point. It's going to be at least 20 years, if not further, if not longer. So it's a little bit of a spatial spin on it, but a lot of it's going to be fairly general as well. And see some command line. Try not to get scared. If you leave, that's okay, but let's go. And put my cursor in the right window to advance. Okay. Version control systems, or VCS. A few other names for that. That's source control systems, source code control systems, source control management. What it is, it's a method to track changes in your files. It could be one file, it could be thousands or tens of thousands of files. But really it's just, something's changed. What is that change? And maybe annotate that change as well. Give it a description. As I said, it's commonly used by web developers and developers. And a note on terminology, because you're going to hear all of this today, changes, revisions, and versions. I'm stick to is a set of one or more changes, and of like Windows 10, for instance, is maybe a very large set of revisions. So changes, revisions are groups of one or more changes. Versions are many versions. And don't get too hung up on the terminology. Somebody else is going to describe it in a different way at some point. I'm not an evangelist or expert. I'd like to think I'm just a pragmatic user of version control who happens to do spatial work in web development. So, the version control system, we'll have them. We use them, and stop me if you've seen this. So, final at the end of the file name, and then maybe another final, and then another final. And not actually how I've done this. This is just an example. You've probably seen this. You're guilty of doing it yourself, or somebody do it. And it's not a guilty thing. It's a way of tracking changes. You're not tracking. It doesn't what changed between them, but you have some sense of order and that something has changed. Another, more likely we've all seen this or received this. Somebody gives you a Word doc in an email, asks you to edit it. You edit, stick your initials at the end of it, and then the next person, and then the next person, and another person, but maybe two people do it at the same time, so you're branching off. You've got different versions going around, and it gets pretty ugly pretty quick. And all track changes in Microsoft Word, but it's ugly. And up until 2017, this was actually basically how I managed my resume. It's all in version control now, but date stamps. And this is a good way if you're working with a lot of files that don't belong in version control, and you just need to make a quick copy of them. Here's a version of this giant set of all these rasters we had on this date, and then we did something on this date. So ways to go about it. But there are shortcomings in all of these methods, and those become our fatal flaws. We start using these, and we get to a point where we can't look back and necessarily identify what changed. Lost changes, think about that email example, two people edit at the same time. Are you sure things have been brought back together? When did this change? Concurrent changes, lost changes, all of that. I think you can probably see pretty clearly how things can rapidly go downhill, especially when you're working with a large group of people. I call Git a real version control system. We saw our little ad hoc methods of controlling our files. They work in some cases. They may be all you need for what you do, but when you do collaboration and you do it with text files or data in text format, a real version control system is what you need. And one of those, you might have heard some other names out there before, Subversion or SVN, Mercurial, CVS. There's some others out there as well, but those are kind of the four big ones that I can think of. So on Git today. So let's think about what some of the core functionality we might need in a version control system is. If we're working Let's ignore collaboration for a minute or two, maybe pretend, and think about what we need to do. And when I think about this, maybe this is oversimplified. You need to save your changes, call it a maybe that so you know what was done. You need to be able to the history of those changes. You know, what when, what was my comment, and I need to be able to compare easily between those versions. So you can say, you know, I updated this web map to point to this new web server in comment. So when you actually look at the code, what's underlying that? So you can have an easy way to view that. Great. I'm going to argue that on the solo user side, maybe you don't really need much more than that. If you can get away with those two things. I mean, obviously you want it backed up. And this is starting off a single computer, but we'll just, it is for now. Maybe it's oversimplified, but it's a good starting point. So let's try how changes are tracked in a version control system. So text files are best. We'll just open with that. And somewhere later, there's a slide that basically says file geodatabases, shape files. Yeah, you're going to run into problems. There are binary components to that. Instead of the version control system saying, you know, this line, this changed, it's okay, this 200 meg file changed in some way. So yeah, its utility varies based on the type of file. But it comes down to, with Git, I believe this is common through the other systems as well, is what lines have been removed or changed, and what lines have been added or changed. It's deletes and it's inserts. You can add a line, where do you need to insert it? What lines do you remove? You're changing a line, you remove the line and insert a new one in its place, or a set of lines. So they're really important. And you'll see some of this later as well. Gigantic one-line files. You get somebody's JSON file and it's 600,000 characters on a single line. Well, when making changes line by line, it's going to come up as line 1 changed. And good luck figuring that out. I mentioned this, I'm skipping around between my bullets, so bear with me. Yeah, you can store revisions for binary files, but again, how useful is that this change? You can have a comment with that, but what about change? One of you or more may walk out, because we're going to talk about the command line. And I'm going to try to argue for this solidly. I've been using control systems since about 2008. I don't know why I didn't start sooner. I should have. And I started with Subversion and eventually switched to Git when the university got an instance of GitHub Enterprise, and more on that later. But I found working with a couple of different graphical clients for Git was that they distorted what goes on behind the scenes. You talk about a version control system and you need to add changes and commit those changes. There are commands that use those words, add, commit, and so on. And you fire up a graphical client and the GitHub client, for instance, I don't know if it still does this, it uses the word sync. I don't know what sync means, because it is not a Git command. It is Hub's idea of things that you might commonly do. But we have a knowledge of what underlies GitHub. That's the command line level. Something you do in a moment. But as somebody who understands what's going on sort of behind the scenes in a pragmatic way, I have something to say, I'm going to do this for you when I don't know what it's actually doing because I know what commands are available. And there are a lot of commands, but there are only a handful of commands you probably need to know on a day-to-day basis. I was talking to the guy behind me in U-Spatial. I talked to all of you still back in December about GitHub, and sort of following through on that, thinking about what I do and thinking about what others are doing. It says, yeah, there are about 4 commands I use on a daily basis. That's all I need to know. I'll call myself slightly more advanced. I think there are about 7 commands I use on a daily basis, and a little more complicated workflow, but there's not much to it. So here, the command line There's not much. There's a lot of slides, but not too much. Identify 5 commands I want to cover pretty quickly, and some of these might be self-explanatory. Tell me what's in my repository. Good terminology. A repository is your set of files that is managed in Git. So what's going on? Has files been deleted, added? What status? Diff, differential, difference, is tell you what's actually changed. It's going to say, oh, these lines have changed in this file, and this file, and so on. This is what's been removed. Git add. Then you go into your repository, and you make some changes, and then you add the files that have been changed. And you can add just one file, depending on what's changed. But that doesn't really say. It says, okay, here's what's been changed that I'm interested in, but then you commit those changes. So kind of like you commit to memory, well, Git commits to Git history. The repositories tracks all of these changes. And Git log, just to tell you, what's going on. What is that history that I am recording? Is this fast? Nobody's shaking their head? Okay. Sorry, command line, this is, some people just hate this. So I'm going to a quick set of slides to show you how easy it can be if you need to make a change in a very basic repository. There's no collaboration here. There's no consideration of running it on a file server, a Git server, or anything like that. It really is just, here's a file. I need to make a change to it. How can I go about this? And this set of, I think it's 10 slides coming up. I'm going to go through really quickly. This is not, once you get comfortable with Git, you're not going to be doing all of this. This is more demonstrative to sort of walk you through it. Let's go through it. So, terminal, daunting moment, I know. Well, here we do a Git case, and all it says is on branch master, no commits yet, nothing to commit. I think I took this early, but basically it says, there's nothing going on. Okay, so I've it's already got a file in it. I'm going to now fire it. I've got this one file, all text, a lot of lorem ipsum, and to change hardly anything. All that changed reasons, and this line was added, and everything else is the same. So really minor. So when I go back to my terminal, and I'm going to do a git status again to see what's going on. So Git will tell me, oh, I see you modified this file. Edited yet. We need to do that next. Sorry, I'm getting ahead of myself. So I ran the git diff command here to actually say what changed, what's going on. And hope those of you online can see this okay. Unfortunately, I'm a little red-green colorblind, so I can at least make a difference here. But you've got red, then green, minus at the beginning of the README line. Okay, the README has disappeared, but inserted this demonstration of basic Git repository. So you've got pluses and minuses, and up at the top, you've got some crypt-looking epsils, and basically that's just saying where am I inserting and removing things. So this is what's going on here. Now we can add our file. And all adding does is what in Git terminology is known as staging something. You staged something to commit it. You haven't committed it. You just said, when I run it, I want to include this. The hallmark of self-implementation is, I don't know, reasonable comments. So, I'm guilty of using MISC for miscellaneous as a comment too often in my own work when nobody else is looking. But generally, you want your commit messages, your comments to be something worthwhile that you can understand, and then if you're collaborating later, somebody else can pick up on as well. And if it's a little, maybe that's okay, because you know what? They can, and we'll get to this later, they can compare and see what those changes were. So you've committed it. And status, okay, nothing to do anymore because we've committed it. That's it. So just Git couple people, sort of some hand waving. So, oh, I'm at the log slide, and you can view the log as well. I may have been redoing some slides this morning because you have date stamps and realized this was a little too small, so I threw off the text. But history, you know, here's my initial commit, and here's the most recent commit at the top with date and timestamp and a comment on it. And you'll see these terribly long hexadecimal strings as well, just commit references. The first settings are useful, but we're not gonna dive into that. That's just the unique identifier for your commit. How useful is that workflow? So again, no collaboration, just solo on your own. Yeah, you can track changes. Okay, and you can copy the directory around your repository within that directory. Behind the scenes is really just a hidden directory in your repository called .git, and where all of this information is stored. So I could copy this directory to another computer. I could stick it on a file server. What mileage is going to vary? Maybe you're going to want to access it remotely. Maybe you want to collaborate. So what? And it collaborates not so well. Again, this is trying to ease you into this. I did skip a couple things. Again, we talked about day-to-day knowledge that you need to use Git, and I didn't show you how to set up the repository. It was one command, git init, and then a file add and a file commit for that initial commit. Unless you're creating repositories every day, that's not something you do. And we tend to find just a handful of commands, maybe 2 handfuls, depending on your workflow. So let's GitHub. I know I've mentioned GitHub, and I will sometimes incorrectly interchange Git and GitHub. The title of the talk was "What's the deal with Git?" and parenthetic bracketed hub. So GitHub is well, GitHub is not Git. Git is a version control system. GitHub is basically a Git server. It's as a service offered by a company, and it is so much more than just Git, because this company has taken Git, the version control system, and added all these tools and other functionality around it. So we've talked about comparing things, versions, for instance. You can do that on the command line, but frankly, unless you're a super command line nerd, you're going to fire up GitHub, something with a nice interface, and you're going to look at changes there. And again, so many tools, we're going to go through some of those. For those of you at the U, which I suspect is all of you, we actually license a product called GitHub Enterprise. We run it on premises. It's single sign-in. So if you have questions, maybe this work shouldn't be out on public GitHub, or maybe I don't want to pay the $7 a month for a private repository on github.com, github.umn.edu. That's how we're doing it in U-Spatial. We've got all of these repositories in there. And really, and a Git server hosts remote repositories. So you think back to our example of adding and committing those few changes. That was a repository. It was on my computer. That's very useful for collaboration. Remote repositories is the way you need to go, and GitHub provides that. We're going to go from working alone to collaborating. And even if you are working alone, if you can stick it on GitHub, stick it on GitHub, because you're going to be happy with what it can provide you with. So repositories, and this is explaining some of this is I couldn't find any good graphics that I liked and didn't make one up. So I'm going to try really hard here to explain, because if you think about some of those earlier examples of the email around, the edits, and chain of initials at the end of it, and how you manage that. Concurrent change in one or a set of files, those changes may happen at different points in the file, or those changes may overlap. It's not always, and if you make concurrent changes, you're going to have to deal with that at some point, because Git or GitHub is going to say, hey, this changed in 2 different places at once. How do that? So think of remote repositories. You keep a copy on your computer, but there's something up in GitHub. and then you and other changes locally to your local copy, and then you changes up to GitHub, the remote repository. And again, maybe you're making concurrent changes. You'll get a warning or an error. You'll have to take some action. Get that those changes that others make from the repository as well. Really, it's the remote repository is the central repository. You're just making a copy of it and updating the copy and syncing that copy back with that remote repository. We'll find it a little bit, but and finally, you can merge your changes with other code locally. So if Kate makes a change and I've been making changes and I see Kate's change, I can pull her change down and merge it in with what I'm working on, make sure there's no overlap. So we've got all of her work, all of my work, put it together and send it back up. Happy with that explanation, but it's going to have to do for now. Can I run a Git server? Sure, but use GitHub. There is, seriously, at the university with the site license or the license terminology these days, there's no reason to run your own. You run your own, you're going to get Git and none of what GitHub has to offer. So and this is just a sampling. There are a lot of complex workflows out there that people can use with Git and GitHub. On your development environment, are you writing code? Are you managing data? Website, or is it C++? It really depends. Is your team 2 people or 2,000? So let's swing through some of what's out there. Access control. Ooh, that's a good one. So you can only blur names there. But this is useful. We've got apparently 9 people with access to our repositories right now. We keep some of the stuff private. Just because there's things in there that aren't private. But, yeah. So you can private repositories on github.un and .edu. Node. Establish teams, add people to those teams, give them different privileges so you can let people look at things but not make changes. I'm not going to belabor this. It's there, and control is good. Issues. Issues is best things I would say about GitHub, and isn't necessarily a problem. Issue is a very Minnesotan way for some people of saying problem. Something is wrong. And issues in this case, it could be a problem. You can see one of the examples down here, or one of the issues, is flagged as a bug, but also docs, indicating that somebody needs to update some documentation. But an issue just be a question. It's, are we doing this the right way, or is this feature worth adding? You're working on your own project. I have done this, and I know other people have done this as well. You have all of these different places to store your source code and your documentation, and are you Word Doc and Google Docs and GitHub? Issues if you want. Ask yourself questions. Assign yourself to do's. Assign them to other people as well. So if you're working collaboratively, you can say, Kate or Lynn or somebody, you need to use on this. And a lot more built in there as well. You can set up milestones if you actually have a solid development cycle, version releases, that sort of thing. But it's, there's so much possibility here. And each of these issues too, I should have had a screenshot of this. There's a comment attached to that as well, and you can throw in images. So you can document so much with your issues. So very cool. Easy, little small, hard to read. This is just a recent change we made to one of our applications. We're just pointing to a different server behind the scenes or something. This would be a pretty way to do on the command line with Git. You can do it. I would not recommend it. I don't think I've actually done it because I know how to do it and I want. But you can see the lines that have changed have been highlighted. In fact, Git these days is nice enough that it's actually noticing what within the line has changed and highlighting just those pieces for us. So very easy to compare between versions, compare across multiple versions as well. What's changed from the commit to what was 10 commits ago or something like that. So you've got a very solid history of those changes. Releases, not something everybody's going to use, but this is the 7 Mile Creek Geodesign project, which is going on for many RAs and many years. And we started versioning it 2.5 years ago, something like that. Just more for sanity, I think, than anything else, because if you remember those long, I think 32-character hexadecimal strings. This is the short 7-character version. It's usually abbreviated. It's kind of ugly, and it's nice to know, hey, this is something that's, I'm calling this a release because this is stable. This works. I can put this on a web server and know what it is, and bundle up all of the code behind it as well. So you do those in a variety of ways, or you can just up here alt tags. Releases have tags. Tags are native to Git. Releases are not. Releases are something you do in GitHub, but tags are pretty powerful. This is an example from the Minnesota GIS-LIS consortium. Somebody over at, I forget if she works for DNR or Minute Services, somebody with the state put together a conference map a few years ago for the annual conference up at Duluth, Bemidji last year, going back to Duluth, and GitHub. And the title of the slide is Web Hosting, because GitHub actually lets you publish a website right out of a repository. So now you track things, version, or make revisions. You can publish that right to the web. So pretty simple repository. If you use the URL up here at the top, it's right on github.io is github.com's web hosting side of things. So that's all running off there. And if you want to collaborate with other people, let them make changes, they can update a website pretty easily as well. Okay, see if we can get by this. So direct editing. This is, we're going to help this. Let me full screen it or try and read. So direct editing, you can edit directly in, you can edit files directly in GitHub. So 2 minutes, I'm just going to walk through it. This is a project that the NHGIS folks are working on. Somebody has created this public housing project where they're trying to track down some data. They've got some students assigned to it. They wrote some documentation. And the students are, I need to, lost this. Okay. Documentation on the process, and the students are editing these files in this repository. So the changes are tracked. So it's a collaborative project, and it's not code. It's not code at all. It's documentation and data. And it works seemingly pretty well for them, meets their needs. And I'll have to ask Dave about this, but it's better than Google Docs. He wanted to avoid Google Docs for this. So we'll see if he still feels that way when the project comes to a close. But anyway, I'll start the video again so I can annotate it. See, the README file was shown, and we click README, and we can look at the README file, how this has changed. Not like this so I didn't muck anything up for him. But here's your history. So just like we saw with git log and the command line, this is what's going on. Backing up, click on Edit this file. And text file edits right up. That file is in Markdown. I'm not going to go too much into it other than to say it's pretty handy. I'm going to change, delete a line. There was a bit of duplicative intro there. And common language, commits. So it knows that I'm adding in this file. I'm committing changes with remove duplicative intro as the comment. That's it. You can update it. So you could do that locally on your own computer in a text file, text editor, or you could do it here. And if you think about learning curves, barriers for entry, one way to go, I'm creating a new file, adding it straight to the repository, and we'll let it play out. Sped this part of the video up, just typing slowly. And just when we were in the previous file, you can add a commit message and commit those changes. I skipped it there just for the sake of time. Okay. Okay. So really, GitHub especially really does a good job of supporting collaboration, and that's just scratching the surface. Again, I've described myself as sort of a pragmatic of Git and GitHub because I'm doing super complicated workflows with big development teams. Most of the work I do is with myself and maybe with one or two other people at a time. But get into collaboration, you get to deal with some fun things like aligning your team, which anybody who's ever worked in a group, which would be all of us, that can be hard. And with code, with data, it can be even harder. Style considerations are huge. Whites, tabs, etc. Because again, we're talking about versioning data. If a character changes, that's a change. That is a revision that's going to be recorded. So if you are indenting things by 2 spaces and somebody else is indenting them by 4, that's a problem because now everything is changing. So style considerations and then effective workflows. So let's considerations, just a few big ones and some high-level points. White space, hey, this person is on either equals, and the next person doesn't. Okay, this is a Git diff, so that's a change. Your code has changed. Is worth recording. You don't want to clutter up your revision history with little things like this. Be it a little white space here, maybe there's a trailing space after a parenthesis somewhere that you have that somebody else didn't. So you've got to watch white space. Tabs, don't use tabs. If you're writing code, just don't use tabs. I'm not going to belabor that. For anybody who knows, and if anybody actually likes tabs, I would be pleased to, wouldn't be pleased to me. Not one of these. 2 spaces, 4 spaces, whatever. Tabs are not spaces. Tabs are not 4 spaces. Here's 4 spaces. This is a tab. It looks like 4 spaces in my text editor, but it looks like, 7 there. Just be consistent with tabs and spaces by adding tabs and agreeing on how to indent things. And finally, lines. This isn't going to come up so much anymore, but a crazy thing. Some people are on Macs, Unix style line endings. Windows has a different style of line ending. And between Mac and Unix, you might get this sometimes. CRLF, which is the Windows style line ending or new line, will be replaced by line feed, which is the new line Unix style. So Git's gotten better about handling that because it realized, or somebody realized, people are developing collaboratively across different platforms. Something like this with that *M, you're working with something really old because that is Quest 10, so that's 15-plus-year-old code or something like that. So I'm not across that, but got to be considerate of all that. I forgot a slide. So consistency, and again, this is really critical when collaborating. Agree styles, and it can be hard. So use existing style guides. They're everywhere. If it's JavaScript, HTML, CSS, Python, whatever it is, somebody has written a style guide. Chances are there are many of them out there. That style guide on itself has in PEP 8. I think it's PEP 8 or PEP 5. Use an existing guide. Use linters. PEP 8 is for Python. It's PEP. I'm blanking on the word, but it's basically what says, here's how you indent things. Here's what you do for white space in all of these cases. If you're writing JavaScript or ECMAScript, there's really all a linter does is complain at you if you're not up to standards. So they have some standards out there set by somebody's style guide. And if you write code and you've got extra white space somewhere, your text editor is going to say, something wrong with this line, and this is what's wrong. Code inconsistently on your own, great, but a linter is a really good way to help enforce consistency when you're collaborating with people. Whoops. Okay. I'm not going to cover this in too much depth because this really depends on who you're working with, how you're working together, what the project is. Are you writing code? Are you managing data? Writing documentation? It's vary, and it's something you're going to need to figure out. You get into issues of, does this code or does this need approval? And there are methods in GitHub to support that. Something called pull requests, where you request to merge code, basically. And you can set up a process whereby another person in your group, for instance, goes in and reviews what you've done. Says, yeah, this is fine, and clicks merge request, or merge, whatever the button says. So again, there's an interesting article, and if I didn't have the link to the slides at the end, we should give that out. There's an interesting article by from Scott Chacon, I'm mispronouncing his name, no doubt, who used to, or maybe still does, work for GitHub. He's a Git evangelist, and this article is about how they used, what they did for workflow at GitHub itself. So I think that'd be a pretty interesting look into how to do it. But they have a very specific use case as well. They're writing a major piece of web software used by millions of people, and they are making changes all the time, every day, multiple times per day, and different people working on different parts. So how do they manage that collaboratively and ensure that when somebody makes a change that they want to get out, they can do that, but somebody else who's working on the same code base isn't going to be sort of behind because somebody changed one thing. So it's a read. I'm not going to belabor it right now, though. Again, it's, get into Git and GitHub on your own, or join a group that's already using it. Take some of this and agree on a workflow. And there are people out there who can guide you in this. But again, it's really situationally dependent. Working with repositories. So you can create them or find them in GitHub. The commands, so we talked about a handful of commands. The commands you won't normally use are provided for you if you need to use them. No need to use them. And there are a couple to create a new repository in GitHub. And there are other ways to do this all. But to just create basically an empty repository with nothing more than a README file, and the other load an existing project that's not versioned. So, if you come into a situation where you're inheriting somebody's code and it's not in GitHub, you can take that code, you can git a init command and a couple other things, and GitHub that way. So we're going to walk through really quickly an example on github.umn.edu. I click a button that said new repository. Okay, I've given it this wonderful, wonderful best repository ever name and a not terribly useful description. I have a public repository, and then because this screen is cutting my image off, you can see at the very bottom there's a button check that says initialize this repository with a README. Basically a mostly empty file that contains the name of the repository and your description. And that's it. I click save or create, whatever the button is that was hidden in that screenshot, and I get a new empty, other than README file, repository. And over here, at clone or download, you're going to see that every repository. I come into clone, and I can get this URL, and then on the command line, I can clone that and make a local copy on my computer. Or if I just want to look at the code and don't need to edit, I can download the file set as well. Oh yeah, here is that's just paste one URL in and have all of that on my computer. Not a, it's a little more involved, but GitHub will guide you through it. It will list the commands for you, and then your handful of what you need to use. So since the main series, I figured we should have at least some slides on spatial data in GitHub. Talked about a little bit about this earlier. First of all, binary files, if you change them, Git or GitHub will say, yeah, the file changed. Okay. Now, so pretty much every raster format out there is binary. There's an ASCII raster format or two. I don't know why you would use them. Probably old software somewhere. But even then, if you're looking for a change in an ASCII file that is a raster, that's a use case. Files, Geo Packages, If you're not familiar with Geo Packages, those are an open source Geo standard package. If you're using QGIS, maybe you've seen them. File databases from Esri and all of these other formats include binary, so you're going to get that, yeah, this file changed. Spatial, a couple of common formats we see are CSV, GeoJSON. We download CSV with a column of X and a column of Y, be they or UTN, whatever the case might be, there. And GeoJSON, if you've heard of it, hopefully you've heard of JSON. It's not as just a computer science web developer sort of word these days. It's really just a text file format for structuring data. And then in front of it is an extension to that to geographic data in a third way. But it's all text under the hood. So working with it's, I assume everybody here has worked with CSV. One record per line, it's super easy. You can make a change somewhere, you can commit it. Really, the only thing that I can think of watch out for with doing this is, so if you sort your data, all of your names are going to change unless the sort is the same. So you're going to wind up with a commit that is basically, I used 3,000 lines and inserted these 3,000 lines. It's the same in a different order. So if you do need to do that for some reason, do it as a commit on its own, so you're not obscuring actual underlying data changes. But forward, and this is, you can create a shape file, file database, Geo package, whatever, off of CSV pretty easily these days. You can do it with a Python script. So, maybe this is a good way to store things. Working with Geo, a little more complicated. White space varies. There are a few different ways to go about it. It's flexible. You put all of your records on one line. You may want to extend it. I've got some screenshots I'm going to jump to for this right now. Just to show you, I downloaded Minneapolis water features from Open Data Minneapolis, and it can be on one line, 660,000 characters on one line. Not useful. Useful if you care about finding the change. And you could put it one feature per line. You've got some really long lines in there because you have some, for whatever reason, super precise coordinates, and a chain of those. So a little easier to track down those changes. Here, if you actually want something human readable, you can format your JSON this way. There are tools to do it automatically. The problem with Vernis is, thank you, getting the 5-minute warning here. There are tools to do this automatically. You just have to ensure they're going to be consistent. Otherwise, again, you're going to wind up with a lot of changes that weren't really changes. One, GitHub and GeoJSON, and not work on Git Enterprise. So github.umn.edu, I don't know why this didn't work, but github.com supports the rendering of GeoJSON files onto a, so I took that Minneapolis water file, made one change, and pulled it up. So of course this image is cut off, but you can see some of these outlines don't fit with the base map. I've got a little up there with attribute data for Lakeland / the new name, which I am unable to pronounce at the moment. But you can view that data this way. Choose go to text. You can do this on github.com or github.umn.edu. This is, well, here, let me show you first. This is another really quick video. Different versions. You can have a time, you have a slider tool like you have in, you can see Africa's changing. Slider tool like you have in ARC map. ARC online applications. There's this onion tool as well that maybe went a little too quick, but basically just changing the opacity of the layers on either. It was in the talk, so I figure I probably ought to talk about it. Dissertations. You can version control your dissertation. I had a very good friend who did it. If you need to use Word or something specific for your program, for your dissertation requirements, do it. If you're feeling a little nerdy, there's this wonderful markup language for typesetting called LaTeX, which as a math undergrad many, many years ago I used because it was the only way to decently typeset equations. text. It's all markup language. So you can track your changes really easily. Again, I'm going to look at Susanna and other faculty members in the room, and don't go against our college's standards, but it's something to consider. And bibliographies, BibTeX is a standard format for bibliographies that goes with LaTeX, also text-based. So I'm not doing a dissertation, so I just pulled up a copy of my MA, and I realized at some point I should add my website to it. So it's some very basic LaTeX code right here. You can track version that just as you would anything else. Issues to ask yourself questions, give yourself reminders. Oh, I need to proof this again. So other things to check out or to consider, because we've really just sort of scratched the surface here today of GitHub. There's so much out there, Git and GitHub both. What we didn't talk about was branches in Git. Basically, you take your code and you make a branch so you can experiment with that on that, maybe create a new feature there, and then you merge things back together later on. Again, it's on your workflow. GitHub forks. You can the project you like. You can fork it. You've got a copy of your own code. You can edit the code because it's yours now. I mean, licenses varying. If you change that you think to go back, you can make a pull request and say, hey, person who writes Gmail or whatever, here's some code. Maybe you should take this. And you can find some of your favorite projects on GitHub as well. So if you want to look at what's under the hood, one way to do it. I'm basically out of time, so except for questions. So a quick list of common commands. I ran through sort of everything I've covered here, everything I use on a regular basis. And that was it. I think it was 13 in the end. Not a whole lot. A init you use when you're firing up a new repo. Clone you use when you're making a local copy. Status add commit log. We've covered reset and stash, just undoing things or hiding things. We've got branches, check out. You all of this up. It's not too bad. And there are some one source is slow. Some great resources out on the web. Check out lynda.umn.edu because we license Lynda. There are a couple opportunities there, and there's a lot in Stack Overflow and elsewhere as well. So thank you for not asking any questions as I went, but we have time for questions. So I'm happy to take anything from online or in the room.
So you are in a group and you don't want to maybe ask everyone to commit my stuff. Is there like a user interface that you like or to be able to like run your code before, like, because like in GitHub you can't be running it while you're writing it. Because like I think, and I know that I think I've heard like Atom is one that you use. Is there anything like that you recommend?
State the question for the online audience. So correct me if this is wrong. So the question had to do with working in a group of people. If you try something out, test some code that has been written, but you do that without interfering with others, is there a good way to do that?
Yeah, like if you're like working on a project and you're making a program, and you want to be like working on a file and potentially making changes, but you need to like run the code, you go to like check it.
Okay. Yeah. It's perfect instance of a local repository, because the remote repository in GitHub, anything you do locally, you're not putting there unless you explicitly say push these changes up. So you've got a local copy of everything. You can do whatever you want, and if it doesn't work, you can git stash your changes to basically say, go back to whatever the previous revision was. If you test something out, branches are often a good way to do that. Branches basically making a copy of defaults. There's something called the master branch that pops up in all repositories, and some people just work off of that. But if you're making a change to widgets, lack of creativity, and you want to create a branch called widget testing and make a copy there, make all of your changes, see if that works, you can do that. So you can do whatever you want locally. It's just a matter of compartmentalizing your actual changes versus playing with this and only pushing up what you want to in the end. Is that?
Yeah, and where do you like save that and like run it?
The code. I mean, I don't know if you're talking about like a website code or Java code that you're compiling, or
I'm saying like using Python.
on your local computer.
Okay.
You're going to run into the issue of
So
do you have
there's like I think that like there must be like things that make this excuses. I was just thinking about like things that support that like you do.
well, gives pretty much anything because it's just a file. They have something called a Git Ignore file, which is going to help you. A Git Ignore file basically says ignore files and folders that match these names or these wildcards. So if you're working with Python and you're running Python code and it's creating a cache directory or a compiled bytecode file, one of those .pyc files, those aren't something you want to be sharing because that's not your code. That's compiled for your local environment. So you can basically tell Git and GitHub to ignore those files. As far as running locally, one thing to consider there is also your environment, particularly the programming languages Python, Java. Do you have modules installed locally? Are you running the exact same version of Java? And even though Java is supposed to be platform independent, it's not entirely. That's kind of a difficult question to answer. One thing you could do if you're writing Python, which I think I heard, you're using Anaconda. Are you using Ana by chance? Oh, great. So, there's good environment management in Anaconda, so you can dump out a list of everything in the environment, all the modules that installed, explicit versions, and then you and your other collaborators can use that file to say, oh, I need to create an exact mirror of this environment on this machine. So your question's going a little beyond GitHub, and I'm happy to talk to you more after. Should probably take another question, but yeah, no, that's a good one. Unless there are no other, in which case we can.
There's nothing online yet.
How often do you do this?
Well, since I'm going to say regularly, that the answer is I commit more than I would to sometimes because because I'm the only person working on a lot of these projects, I also worry about my hard drive dying, doing some changes because we all make mistakes. So I will, and so I said don't do it earlier. I will commit with like in progress and miss because I'm not messing anything up. A good general rule for when you commit is when you've done something significant. And significant could be I fixed a typo, or it could be I wrote 400 lines of code to do something phenomenal. It's kind of where the group you're working with in. But unless it really is just a typo, don't go anywhere. If you're updating a lot of documentation at once, roll that into, then 3 typos, and I edited this section and this section. Roll it in one. But again, it's going to depend on you and the group you're working in. So
it's hard to use commits. Commits can be used as a backup.
Push it up to the server. Yeah.
Server. Then that's a string container module.
Yes, because you have that wonderful history, and this is not something I do, so don't look at our repositories. This is not something I do, but you can, and I think you would have to do this. I don't know if you can do this easily in GitHub or if you got to go back to the command line, but you can group together a set of commits and generate basically a file that describes all the changes from one point to another point, spanning however many commits. And then you can go back to that point where you started from, apply, and then commit all of that at once. So there are ways to take this sort of maybe hard to follow chain and grouping it into one commit. So, and if you're using branching, you can do that on a separate branch and do whatever you want, and then put it all up into one nice package commit and push it back. Again, it depends on the group. For me, nobody's looking, so. The easy answer, I should repeat online, just a question about, are there good conventions for bringing in somebody to do a code review, look at maybe an external person looking at code from a group? I think there is yes. In GitHub, well, if they're doing a really solid, thorough review, they're going to want to look at everything. They're going to want to see how you're maintaining that history as well, your commit messages. But with GitHub, you could use access levels to, let these auditors, whoever they are, in and look through the code, look through the history. They could open issues. They can make a local copy and step through things themselves. So review standpoint, give them access repository, I would say. Now, if you want to do code review on an ongoing basis before something gets into production, for instance, pull requests in GitHub are a good way to do that. Pull requests in conjunction with branches and forks. You write your code and you say, okay, this is good, and you make a pull request to say, I'd like to move to the master branch. And you can have your own workflow established with this group that says, somebody else needs to, or 2 people or 3 people, to review these changes and sign off on it before somebody says, yes, this is okay to merge. So did that get to the answer? And I'm a code expert, so there's probably an authoritative way to do that. I don't know what it is. I'm a pragmatist. Anything online or in the room? Or? No, I'm all for coming and popping online, and hope this is a start to the spatial exchange, and maybe Kate wants to remind people on the next one. I don't know.
Yeah, next one is April 4th at 4 o'clock and plug in 4:45. Thank you.